Example 3, we want to test the claim that the mean weight of all RCC students is different than 150 pounds. We have a sample of 43 students that resulted in a mean of 163 pounds and a standard deviation of 25 pounds. And we're going to test this claim with 5% level of significance. So the information that we are given in the problem is that mu is equal to 150. Since we are testing the claim that it is different than 150, we will take mu equal to that. The sample had 43 students in it, so our sample size n is equal to 43. That sample gives us a sample mean of 163 pounds, so that is our x bar. And it also gives us a sample standard deviation of 25 pounds, so that is our s. Our little s is 25. So notice we do not have the population standard deviation. This 25 came from the standard deviation of the sample. And so we are going to be using the t-distribution table because we do not have sigma. Our alpha level of significance is 5%, which as a decimal is 0.05. And so our level of confidence is 1 minus 0.05. And so we will be 95% confident in our conclusion. So now we are ready to begin with step 1 of writing our hypotheses. Our null hypothesis, HO, is that mu is equal to 150. The null hypothesis always gets the equal. Our alternative hypothesis, HA, we're testing the claim that the mean weight of all RCC students is different than 150 pounds. So our HA is that mu is just not equal to 150. We're not seeing if it's greater than or less than, we're just seeing if it is different. So different means not equal. Step 2, we will calculate our critical value we will calculate our test statistic. Step 2, we will calculate our test statistic using the formula that t is equal to x bar minus mu divided by s divided by the square root of n. Our x bar is 163. Our mu is 150. Our sample standard deviation is 25, and our sample size is 43. And when we round this to 2 decimal places, we get a test statistic of 3.41. So now we are ready to move on to step 3, where we draw our rejection region and determine what our critical values are. So I'm going to be drawing a bell curve. Our alpha is equal to 0.05, and this is a two-tailed test. And this is a two-tailed test because when I look at my alternative hypothesis, it has a not equal in it. There is no inequality pointing in either direction. So whenever you have a not equal, you have a two-tailed test. So we have a two-tailed test, and we need to share alpha between these two tails. And so the area of one tail is going to be the value of alpha divided by 2. So when I take 0.05 and I divide that by 2, we see that the area in one tail is 0.025. So each of these tails has an area of 0.025. And I will shade both of those tails, and those two tails make up our rejection region. And so now we need to head over to our t-distribution table to see if we can determine what our critical values are. Our degrees of freedom, we'll need that when we look at the t-distribution table, is equal to n minus 1. Our n is 43. 43 minus 1 gives us a degrees of freedom of 42. So now with that information, we are ready to head over to our t-distribution table to see if we are able to determine what our critical values are. So looking at our t-distribution table, we have a two-tailed test. So we are going to be looking in the column with two tails, and our alpha value is 0.05. So we're looking down this middle column here. So looking down this column here, our degrees of freedom is 42, But our table jumps from a degrees of freedom of 40 to a degrees of freedom of 45. So our critical values is going to be something in between these two numbers here, what's given for 40 and 45. But to be able to find it, we're going to have to go and use our calculator, since our degrees of freedom does not show up explicitly on our t-distribution table. Now, using our calculator, we will be able to find this critical value here, this one on the left side, that negative critical value, and the positive critical value will just be the opposite of that. So to find that on our calculator, we're going to hit second vars to get to DISTR, the distribution, and we're going to go down to INVT because we want to invert the t-distribution. This is going to ask us for two things. The first of which is just going to ask us for the area. I've already filled that in. The area it wants is the area to the left of the value you're looking for. So since we're looking for this critical value here, its left area is 0.025. Remember, we split that 0.05 into 2 for the two tails. Our degrees of freedom is 42. We hit enter on paste. It pastes that function into the calculator for us. And then it gives us our negative critical value, which I will round to 2 decimal places, of negative 2.02. When I round that to 2 decimal places, I get negative 2.02. So our second critical value is a positive 2.02. So now that we have our critical values, we are able to move on to step 4, where we take our test statistic of 3.41 and we drop that into this picture. 3.41 is larger than 2.02, and so that lands in the rejection region. And so because this lands into the rejection region, we make the decision in step 4 to reject HO. We reject the null hypothesis. And so since we are rejecting the null hypothesis, I will cross that out. So we are accepting the alternative hypothesis. So now we're ready to write our conclusion. And this conclusion is with 95% confidence. And we know that because our level of significance was at 5%. So that leaves 95% confidence. There is enough evidence to support HA. And HA is that the population mean weight of RCC students is different than 150 pounds. That concludes our conclusion that with 95% confidence, there is enough evidence to support that the population mean weight of RCC students is different than 150 pounds.